Actually, I'm going to run the program tonight with great help from Elisa Henry. Can you all hear me okay? Just give me the thumbs up. Awesome. I want to start right at 6:30. Awesome. Look at all your smiling faces. That's awesome. I'm new to this, so we're going to have a lot of grace tonight, okay? But I think it'll be fun. Are we okay, Elise?
Yes, I'm ready whenever you are.
Okay. Wonder if everyone's here.
We have a few more joining, so.
Okay.
Hello.
I need one of those cool Zoom backdrops. Okay, what do you think, Elise? Okay, I think we're gonna get started. Thanks for showing up, everybody, on such a cold night. Glad you're here. I'm gonna share some technology with you guys and hope that it sparks some imagination and creativity on your part as to how to use it. It's a broad and varied topic, and you could take it as far as you'd like or keep it as simple as you'd like, whatever your interests are. But a few things first. Everyone who's here, could you please in the chat box give me your name and maybe your grade or your age and your county, and that way that'll help me in the future target some of my content. And also, while I'm talking about this, if you wouldn't mind letting me know what kind of GPS receiver you have, what kind of smartphone and apps you use, and or what kind of drone you have, that'll also help me figure out how to direct my content in the next sessions. So thanks for that, and we'll have a good record of that. So I'm gonna start sharing my screen. Let's see. Oh, we're at the end already. Nope. All right. From the beginning. Okay. Thumbs up, everybody can see that okay? Okay. All right. Let me move some of your smiling faces out of the way. All right. GPS and drone aerial mapping. If you're here for something else, you're in the wrong spot, but here we are. We're gonna have to start with the GPS topic a little bit because it's kind of central and basic to everything else that we do. So in the most simple of terms, GPS answers questions for us like, where are you? Do you know where you are? Do you know how to communicate that to someone else? Okay. This isn't going to help us very much. We need to be on the globe. We need to be on planet Earth. So there we are. We're on the globe. We can see North America. We can see South America. But to use GPS, we need to be on planet Earth. So this field is rife with acronyms. So GPS stands for the Global Positioning System. It's the satellite technology that we use to locate anything on the planet, anything on the Earth, by using a grid system or coordinates. And this helps all of us on the globe talk to each other and share information about locations and geospatial information. So for example, here's our globe. Here's the grid system. Lewistown, Montana is located at 47.0625 degrees north and 109.4282 degrees west. The grid system, as I've said, is this layer laying over our globe comprised of latitudes and longitudes. And let me change that. Yeah, those are the very basics of what we're going to cover early on in this webinar series, and it'll get more complicated as we go on. So GPS was developed by the US military approximately 1973 for national defense. I think we all understand how important strategically coordinating our defense system in times of war was super important. So this global positioning system allows all of our national defense to coordinate our operations. So it also became free to use for us civilians in about 2000. So yeah, there are a lot of applications that have happened since it's been made available to all of us. It's still heavily used in the military. Transportation uses it exclusively, and our world would not be the same if we did not have GPS technology. Yeah, the interesting thing about all these industries and you as young people, this technology is only going to grow and be used more extensively in a lot of different areas, as well as you guys as scientists are going to figure out how else to use it in your world. It's a fundamental tool and it's not going away. So yeah, 2004, your phones got GPS enabled, and yeah, we've been getting lost ever since. Not really, we've been getting found too. So I really want to expose to you a lot of ideas about how GPS is used in ag and natural resources specifically. So I have a few videos. Take a look and see what we think here.
This is Sheeplebein Farm. It was founded in 1955 by my father-in-law. Currently, there are 8 families involved in this family operation, and currently we have 800 registered Angus cattle and 1,200 cattle on feed.
My team is creating a GPS tracking device that would be placed in an ear tag in cattle. It would notify the owner when the cattle would break the barrier and be out. That way the farmer doesn't constantly have to check his cattle.
The tag issue evolved when we had some cattle up in North Home, which is about 4 hours away, and the cattle got out in the middle of the night, and it was quite the feat to try to get cattle in. So when the story was told, the kids decided to make a track on a phone where the cattle were.
So we came up with the dimensions of our tag, the size we would like it to be, and then when we received the GPS, we developed the ear tag further so that the GPS would be able to fit on the ear tag, but not get in the cow's way.
When we looked at an ear tag, we realized it wouldn't have been big enough to actually hold the tracker and have our numbers written for the identification. So we actually took it to a 3D printer to see if they could extend the tag to make it longer so that we could have the tracker on the lower part and then have the number written across the top.
We worked with Eric from the DNR on how they track the moose, and we were able to learn how they power their collars on the moose and how they are able to last so long.
At first, we started looking at solar because we figured, hey, they're outside all day. They should be able to, generate solar. But then we realized we'd have to have a really big solar panel, and that wouldn't fit well on the ear tag. So then we went with GPS tracking, and we had to figure out how the battery life would work. And so we've got it where it lasts 8 hours right now, and we're hoping to improve that over time. overall, we're hoping that one day we'll be able to have it like a pacemaker where it's an instant charge. So every year when they go through the chute, they'll get an instant recharge and then the tag is good for another year.
My team would be interested in getting this item patented, as it'd be able to help other farmers, and it takes a lot of stress off the farmer.
As anybody involved in the ranching industry knows, cattle have a mind of their own and they like to do their own thing. And this is just another way to track them without you physically having to be there. If conditions aren't perfect, you know where those cattle are at all times.
I think the Science of Ag Challenge will really help me because it really helps on problem solving because you actually have to really think through it and go, okay, this didn't work. So now what am I going to try to figure it out? And this year through problem solving, I've learned that I've actually wanted to go into research and development in the food industry.
It's taught me to work well with others and especially my teammates. And it also showed me that it's not always going to work the first time. You have to try and try again. And that way it can be the way you want it, make it perfect.
Awesome. Now let's see if we can, okay. So here's some other ways GPS and drone aerial mapping is used in ag and natural resources specifically. Farming and ranching, we'll have some videos of that. Yeah, migration corridors, I can't really see that side of my slide for some reason. Let's do this. Oh, well, okay. Education and outreach. A lot of us use geospatial information in our projects. So a way to share that geospatial information in our PowerPoints and our information and storytelling to others, it really makes our information pop. It's also a great way to learn using geospatial information. Drone aerial mapping has a lot of application in our world today. We'll get into that. And GPS is also a great use in any outdoor activity, including hunting or, yeah, sky's the limit on imagination there. So here's another video on precision agriculture in particular. Let's see if this one works. Yes.
During our Farm Basics time today, we're going to talk about how do farmers use GPS.
Well, GPS means global positioning systems. And when you think about that, if you're using satellites to guide tractors and farmers doing different things in the field, it seems a little far-fetched, or at least it used to, but it certainly isn't anymore. There are many ways that farmers are using GPS to help them with farming practices.
Okay, the thing that I think is most important on our farm, number one, is how we can go out in the fall with strip till, and then we can follow exactly right to the line in the spring with the planting. Without GPS, we would not have been able to do this. So we're marking those lines and we're setting those lines in the fall with the strip till machine. And now we can come back in the spring and plant right over the top of that. And here's the advantage to that, by the way. It's if I can get the planting done just right and very, very consistently, that means I get those plants out of the ground at the same time. I maximize my stand, I maximize my yield.
And by strip till, Brian, means doing tillage just in a very small portion of the field. So if we have rows every 30 inches, we may till just 6 or 8 inches wide and plant that seed right down the row. And not only that, with that strip tillage machine, we can put the fertility that each plant needs right where that plant's going to be. That's pretty fantastic, and it really has improved things on the farm.
For a lot of farmers, they think auto steer is the very best thing on their farm, and I think it's awesome as well. Well, auto steer technology is made possible because of the use of GPS. And with auto steer, what that allows farmers to do is be much more accurate in all their applications. So there's no more overlap or over application of chemical or fertilizer or seed. This is all done much more accurately and precisely.
GPS technology has also made variable rate applications possible in agriculture, where we can soil sample to these specific spots. Then we can vary the rate of fertilizer that goes on each acre of the farm. We can change up which nutrients go out there, and we can also change up how many seeds we put on each acre to take advantage of that fertility.
What Darren and I have listed here are just some of the ways that farmers are using GPS today. So the big thing we wanted you to understand, if you're a non-farmer, is that GPS is an incredibly important technology that is used in farming every single day by millions of farmers around the United States.
One thing that has allowed is targeting certain weeds as well, like our weed of the week. You identify this week's weed?
Okay, everybody, extra credit if you can identify that weed. Yeah. Okay, we have one more. There's maybe a couple more, but I hope you're getting the idea that there's a lot of ways we can use GPS and ag and natural resources. And again, I want you all to be thinking about this technology and what your interests are, and how you might perhaps use it in your community, on your farm, on your ranch, to solve problems, to tell a story. Yeah, and to explore. So let's watch how it's used in migration studies.
It's a unique look into how big game animals migrate across our state. It's also an innovative way for the public to better understand the routes Wyoming's big game animals have used for generations. The Wyoming Migration Initiative, a project involving wildlife researchers at the University of Wyoming and cartographers at the University of Oregon, advances the understanding, appreciation, and conservation of Wyoming's migratory ungulate populations by conducting data migration research, creating maps from these data, and sharing that information. University of Wyoming professor Matthew Kaufman is the initiative's director and co-founder.
Migration naturally lends itself to being depicted on a map. And what we hope that the people will get is just an appreciation for
Right here on your, yeah. Is it not working?
I lost the sound. Let me
Big
see.
game have been funded and conducted by state and federal agencies, university researchers, environmental consulting firms, and non-governmental agencies. These data have now been compiled and made accessible through the initiative, and helps illustrate issues such as the importance of conserving migration routes. Recent work by the WMI shows for the first time how elk, mule deer, moose, bighorn sheep, and pronghorn all use Wyoming wilderness areas, mostly as high country summer range, but also as migration corridors. The migration requires vast landscapes, which means private, state, and federal lands are just as critical. An example, the recently discovered red desert to Hoback mule deer migration that originates on Bureau of Land Management winter range in the Red Desert, extends north across the foothills of the Wind River Mountains on public and private lands, and ends on Summer Range in the Brobant Wilderness area, a nearly 2-month journey of 150 miles. The vast distances these animals cover each year is fascinating. It's also key in sustaining Wyoming's abundant big game herds. The Wyoming Migration Initiative is giving us another look at our wild friends and a larger appreciation of them. This is Ray Hageman with the Wyoming Game and Fish Department.
Okay. I'm hoping everyone can hear these videos okay. I'll break up the videos because I think they're way more fun than me talking, but we've been working on these GPS and drone aerial mapping programs in rural Montana for a while now. So we wanted to bring it to all of Montana 4-Hers. And it's a really great fit for Montana 4-H for a lot of reasons. You can read all those in the circles, but what I wanted to show you, let's see if my little pointer works. Okay, is that obnoxious? Anyway, these two girls in a rural middle school in eastern Montana, this was their first opportunity to use GPS receivers, and right here we're geocaching, and there's the geocache, that camo colored tea box. There's a little bit of chocolate candy that was in the geocache, which always makes it fun. They have an aerial map, and they have a worksheet where they need to record the coordinates of where they found the geocache. There's a compass somewhere, maybe around their neck. There's a GPS receiver around their neck somewhere. So anyway, they're having a lot of fun, and they're outside. So, and they're learning a lot of, believe it or not, trigonometry, geometry, a lot of math, a lot of technology, while having fun. So there's a lot of ways that GPS and drone aerial mapping can be used to have fun, to be outside, to solve problems, to participate and learn at the same time. So drones are another piece to this, and here's a quick video. I hope you can hear it and see it. Okay. Oops. All right. So this is a place where I wanted to show you something completely different, just because I think we all know kind of what some general applications are, and you guys are going to be brainstorming on those. There's also a thing now that's called GPS art, which creates some amazing art, but there's also, it's used in a variety of ways. So this is just another one, again, to expand your thinking and help you come up with ideas of your own of how to use this technology. So there's no video to this, but we've all used a Strava system or a bike tracker or a running tracker. So this is an app called Relive, and you're able to wear your GPS receiver, put it on your body, put it on your bike, and make a picture on the landscape. That's what this gentleman is doing. What's really fun is there's a lot of data this GPS is collecting that you can analyze. When I looked at this the first time, I'm like, oh my gosh, look at the elevation, look at the terrain. This is the profile of what he's doing. And then I thought, oh my gosh, is he running? That's a huge route. But no, he's on his bike and he's riding around Vancouver, I believe. So can anyone see the owl that he just made? It's kind of sideways. Oops, sorry. I hope you could see it. It was an owl.
Okay, so just replay it or clicks your share screen.
This one, this one. You are screen sharing.
Okay.
New share?
Yes.
All right.
And
then
you'll
go
click
back.
your video that you were playing.
Oh,
That one. Click it
did it not play?
and hit share. The blue button.
Oh, okay.
and
now-
then now play it.
Oh, it didn't play?
Because
This-
it's fine.
Okay.
Now you can tell them, here's your video.
Oh, shoot, sorry. Is it playing? Let's see. It was playing on my computer. This guy's taking a nice bike ride around Vancouver somewhere with the GPS strapped to his bike. Okay, now can you see the owl? It's kind of sideways on the screen, but it's an owl sitting on a twig. Okay, just something fun. All right, now I'm gonna have to figure out how to get back. Elisa, oops. Sorry, folks.
Where do you need to go?
So this is the one that went outside, and now I need to get back to the PowerPoint
Okay, so minimize that. There.
up here.
Mhm.
Oh, okay. Oh,
And
now I'm
then-
back into it.
Now hit your zoom. And let's see. Yeah, that blue zoom.
Oh, this guy.
Mhm. That's weird.
Okay, should I just go back from?
Where is it?
I need to make it bigger.
I'll go on this side.
Okay. It made it really tiny, huh?
I've been
Share
having a
screen.
hard time seeing what I'm doing. I've been winging it.
Okay. Now you want to share this one?
Okay.
Right.
Yeah, but we're done with that one, right? They all saw it, I
Yes,
hope. Okay,
yes.
so now we can, oh, we gotta go back to the beginning.
Okay. Play from beginning.
Oh, can we scoot down to the slide? Yeah, that one.
Okay. Let's see. I didn't mean to click that. Sorry.
Yeah. Just
Current
yes.
slide. There it is.
Okay, thank you. Sorry, everyone. Thank you for your grace. Okay. So there's a lot of pieces and parts to using these technologies, and this whole webinar series was put together with some of these, slowly building our skills to be able to provide an academic understanding of what's going on so that you can critically think throughout this whole series. So here's some of the pieces and parts. GPS basics will be next session. We're going to go through some geocaching. I know a lot of people do this already, but there's a lot of fun things we can do with it. It gets us outside, it gets us hands-on with the technology and having some fun. We need to understand aerial photos and map and compass use. This may be a repeat for a lot of you, but Google Earth is a free application on your computer that really ties together a lot of what we do on the ground and bringing it into the computer realm and making sense of everything. Part of that juncture is, say we want to log points or log locations on the ground of things we're interested in. These girls happen to be mapping weeds. This is a weed flag right here where a scientist went out and mapped some weeds at a state park. And these girls are GPSing the weed polygons and then uploading them to Google Earth and creating maps for the state park to use. That's one application. Drones, we need to figure them out. We can go over what type of simulators we can use on the computer so that we don't crash our expensive drones on the first windy day, the first time we use them. There's a lot of rules and regulations that we want to make sure we understand to be good citizens in the airways. Mission planning and flight parameters. What are the essential components we need to pay attention to when we're out flying our drones? And a lot of what I've worked with in the past with drones, and a really great application is creating large-scale aerial maps from photos that we take using the drone. So we go out and fly a mission with our drone and take photos, and then we come back into the office, and using various softwares, we can stitch those photos together and create a map. So this particular map is of a stream where, again, the landowner wanted a pedestrian bridge across his stream, and we were trying to look at some of the dynamics of the stream and get some distances and different engineering standards from the maps. So that's one that we actually flew and stitched together. Then any aerial photo, needs a scale. So a scale meaning 1 inch equals 100 feet, 1 inch equals 5,000 feet, etc. So these are some of the topics we're going to talk about in these next series of webinars. And it's really a challenge for me to try to make this fit for everybody or every specific use. So keep your questions coming, and we can see who's interested in what as we go forward. So again, my hope is that this sparks an interest of your very own, that you can find a way to solve a problem or explore an interest, and use GPS and drone aerial mapping to help. So maybe after I'm done here, you guys in your groups or in your homes can brainstorm about how you could possibly use these technologies on your ranch, on your farm, in your community, to have fun. So yeah, that's it. I think I got going a little quickly, but I wanted to say again, my name's Tracy Novak, and I've been working with this technology, gosh, 30 plus years now in industry, and wanted to just share all this with those of you who find it interesting. So the next webinar next Tuesday, no, a week from Tuesday, every 2 weeks, we'll do GPS. Again, put your name and grade or any of that information in the chat box. Drone, GPS, smartphone app, so I get a better idea of what people are using out there. And also we're recording these webinars, so you can review them later. It's always best to kind of come to all the sessions and learn the information as we go. It kind of builds on each other. It's kind of hard to pop in and out, but please do that if that's what you can do. So yeah, that's it. Elise, do you have anything more we need to add, Elisa?
Yes, so there was a question. What do you recommend to someone who does not have a drone yet, but is looking to get one and begin working with it?
Yeah. So, that's a great question. And I realized that I should put together a list of some good starter drones, and all drones have different applications and different levels. So good question. I should get a list out to you guys now so that you can start shopping around. So by the time the spring comes and we can get outside, you can maybe have a drone. Sorry, I don't have an answer for you right off the top of my head because it's a little bit complicated, but I'll put something together and get it to you. Anything else, Elise?
I don't see anything in the chat box. If you would like to unmute yourself, you can, and ask us any questions if you have any.
Okay. So do you want me to mute myself and ask questions?
No, I was letting the chat.
Oh, okay.
Oh, my mic don't even work.
Any questions, or should we just stop it here and pick up in 2 weeks? Oh, is this Felix Becker? Did you want to? Elise, I don't hear anything. Should we just sign off?
Yes, that's fine with me.
Yes.
All right. Bye, everyone. Thanks for coming.
Bye. Wait. Is Dad still here? Oh, god dang it, he left. Ugh.